Okay, so the memory card of the camera has now been reset, so we can actually record the second talk.
Actually, feel more comfortable talking like this. But anyhow, so we're going to have the second talk now. There's going to be more time to mingle afterwards. Yes, do stick around. The format's the same thing. We'll have a talk, Q&A, and honestly, I have nothing more to add, so enjoy.
I'm going to try talking without the microphone. Can everyone hear me? Right, perfect, awesome. So I'm Yasser. I'm one of the co-authors of DeepStream.io, which is an open source server. Has anyone used that before? Cool. Who here is a nodeJS developer? that is also useful. Okay, so what I want to talk about today is maintaining real-time performance in a real-time nodeJS server. So just a few weeks ago, we done a new release. I was super excited. We bumped up performance by about 15%. And I was like, this is great to give a talk about. The actual description of the talk, I would say, is more of a lessons learned in a bunch of ways you can avoid doing performance, screwing up performance using nodeJS. Got my words. Okay, I got a lot of slides, but all very short. So what I want to do first is just take you a bit through memory lane of how I first started programming, really quick. So start off with Java. I mean, I'm guessing no one here started doing nodeJS straight out of the box, right? Did anyone? One person. Awesome. Okay, so I started Java applets. You done threads, which basically meant you'd spend ages reading about threads, what threads actually mean. You'd end up like attending lectures where they talk about two aliens entering a bar. It'd be very confusing. And thankfully that only lasted a few months, and I found myself thrown into the browser, which is perfect, right? So goodbye threads, everything's an event loop, you don't have to care about that. So that's awesome. The problem with that, however, though, was I was working on this for about 2 or 3 years, and it's a FX-based trading application. And the catch was that it was based on IE6 and IE7. So everyone who now thinks there's issues in Node.js performance or JavaScript, they have no idea. So they didn't actually have they still don't have decent debugging tools in IE to the extent, so you had to use Dynatrace, which worked really well, I mean, for third-party service. And what I realized is after like a month of debugging of why IE basically kept on crashing, you'd realize that just using a for each polyfill in IE completely screws up, like it would literally crash the browser, right? Or if you use the observable pattern. So a lot of people nowadays love the observable pattern and stuff. And the thing about Chrome and V8 and stuff is it really hides away the amount of times things gets called. You never really take into consideration how often something gets called. When you're running in IE6, however, and every single call takes about 100 milliseconds, you kind of get the gist of it, and then the browser crashes. And finally, the last thing as well is it's a browser. So you also have CSS issues, you have all the things on top of that. So IE7 had a beautiful bug with a hover CSS attribute leak. So eventually, that entire application would crash as well. And this was basically my life for quite a while. And again, the most interesting part in this, and the reason why I want to bring this up, is the fact that all of these issues that I faced, they weren't just things in IE6 and IE7 because IE6 and IE7 were terrible. IE6 and IE7 was terrible, but it was also really, really like revolutionary for its time. And the fact that you were able to build that in IE6 actually like attributes to that. And a lot of the issues that we found, we actually had in Chrome and V8, right? They were just super negligible. You never really noticed. You'd be like, okay, it's like this takes a couple of milliseconds more than it should, it doesn't matter. And then when you fix it in Chrome and use Chrome's amazing debugging environment, you'd realize that you'd get these insane improvements in IE. Like we're talking about tens of kilobytes in Chrome would result in like hundreds of kilobytes or sometimes a megabyte in IE. Right? Obviously this is a Node.js talk, and a few years ago I found myself in Node.js land, which was even more awesome because they have the DB and everything running under the hood. And there's no UI to care about, so it was just a breeze in the park. It was like I started doing it for fun, and then I realized I can get a job with it, so why not? And this is obviously the event loop. So the idea is you don't have to care about threading, and it just works. And the event loop has proven time and time again to actually be better than threads. As like for most programming aspects, for web servers and stuff like that. A lot of people argue that threads are really important, and they are, but we generally screw them up all the time. No one really gets threads correct. in most, like in a lot of applications and stuff, whereas this just allows you to concentrate on actual performance. So based on my new experience in nodeJS and stuff like that, I decided why not, I'll just write a real-time server. And for those who don't know DeepStream.io, a very basic description, okay, a pretty long description would be, it's a scalable server, and you can scale it either centrally or distributed. It's real-time, which means that it tries to send out all data distributions in milliseconds. It does data sync, which means that it's similar to what Firebase does. So not only does the data get distributed, it also gets saved in a cache and storage layer. It does event pub/sub, like push and stuff like that. It does request response, which kind of replaces Express and a lot of things. Authentication, permission, middleware. It does a lot of stuff. Like, we were super ambitious, and we're like, this is going to be like a server that will replace the world. And I mean, we managed to get most of it done, which is great. And so our ambitions were quite well met, but the catch was, obviously, these are all different aspects, and there are lots of different things, and because of that, we kept on running into performance implications again and again in different areas. So what I want to do today is basically talk about the kind of problems that I ran into. So just so you have an idea, when we start looking through code and stuff like that, this is basically how you would deploy a DeepStream cluster. So you deploy a bunch of servers in an auto-scaling group, they use a messaging bus to communicate, and they can store their data in both the cache and the storage layer. And the most important part as well is we don't optimize for one type of cache or one type of storage layer. So you can connect to RDS, you can connect to MongoDB and stuff like that. So we can't do some really, really good performance improvements that would basically screw everything else up. So first off, I'll talk about tools of the trade. So who here cares about Node.js performance? Okay, that's a very good amount, because we need Node.js developers. And who here has used like the V8 debug and CPU profile and stuff? Okay. I mean, the cool thing about this as well is even if you're doing front end, because it's JavaScript, it's both exactly identical. So the first thing I want to talk about, I'm just going to mention these really quickly. So the first thing we have is JSPerf as benchmark.js, which is awesome. So you could say, what's the comparison between doing, I don't know, split to different regexes, or between doing all these different types of things in JavaScript. You have fastbench, which is basically just a much more lightweight version. And then you have my benchmark.js file that I knocked up in about 5 minutes for this demonstration. The next thing we have is the V8 debugger. We'll go into that in a bit more depth in a bit. And the next thing we have, this is just going more and more hardcore down the Node.js rabbit hole. We got optimization flags. So when you run any one of your Node projects, it would tell you V8 would spit out every single time a function was able to be optimized, and every single time it was de-optimized for any reason. So you basically get complete transparency into the JIT compiler, right? And finally, and my favorite, you got Hydra. And I have no idea how this works, but it's awesome. Hydra basically is a really well-known enemy from, okay. Hydra is this, I'm only going to demonstrate it because it's really cool. And there's a lot of talks about on the internet, and it's way, way above my thought level right now. But the idea behind it is when you're running Node.js, you can it dumps out all these logs, right? And it gets like these really, really verbose logs from the V8 engine. And most of the time they're really good. The problem is we can't really make sense of it. People say you should grep it, you should realize what the de-optimizations are. What Hydra done is, and I ran this with that server and it actually worked. So what Hydra does is it shows you the actual code, the JavaScript code that you run. It also shows you a graph. And this is the graph of the compilation steps that actually happen within whatever language V8 translates down to in an assembly. And then finally, you can actually see the steps themselves, right? So again, this seems like extreme overkill. And the reason why I actually got really interested in this is Hydra's author was giving a talk about how just using some of the new ES6 features created the worst trees possible. So every single one of these trees here are basically an operation that's happened. And the color is defined. Actually, I might be able to show this. No, I don't want to spend too much time on this, but generally speaking, let's really quickly see if I manage to do this. It actually gives you a very detailed demo. It's really cool. So the idea behind it is, let's see quickly if I go inside the graph. No, okay. I'm not that experienced with this. I'm trying to play around and try and get my head around it. But the idea behind it basically is you can start highlighting over certain things like this basically. And then what it says here is this function got de-optimized. The reason why it got de-optimized in this case is really interesting. The loop was really hot, it ran lots and lots of times, and then it saw this function for the first time ever, and it was like, I don't know what parameter types it is. So it de-optimized the function. You don't really think about these kind of things when you do like nodeJS, and you shouldn't. There's a really good argument about micro-optimizations and such. But it's nice. It's fun. Maybe. Okay, cool. So the golden goals of any JavaScript application, right? The first one is single thread. You only have a single thread. Exit as soon as possible. Your goal is you exit. If you're going to find something like an O of n square, if you find nested loops in your code, most likely you're doing something wrong because it's meant to be something that exits really quickly. This is really well known in Express and HTTP servers because it blocks the entire thing. And at the same time, it's like in Deepstream, where we use WebSockets and we try and fan out hundreds of thousands of messages a second. Having a for loop is quite a bad thing. Or nested for loops you can't get away from. The garbage collection. The garbage collection is pure evil. Right? Always treat garbage collection as your worst nemesis if you're looking to build a real-time application. Hopefully we're going to see a few demos going forward. And it's like you'd see a chunk of garbage collection that might kick in that takes like 10 seconds after like you do hundreds of thousands of updates. That's 10 seconds of paused execution inside of your JavaScript thread. That's something that's really bad. All right, so now I'm going to try live coding. Okay, so the first thing I'm going to try doing is I'm going to give some basic examples in just JavaScript land and like about some pros and cons. So the first thing is going to be binding and closures. I mean, binding closures are it's the thing about JavaScript, right? It's awesome. When .binds came out, everyone went like crazy. They were like, this is amazing. I no longer have to deal with scope. So let's look into that, into one of my many, many windows. There we go. Awesome. Okay, so let's ignore that. So, what was I doing? Closure. Right. So let's see first here. So these are my three functions, right? I got a scopeless. Can everyone see? Yes, I don't know how to turn Sublime's color scheme. Sorry about that. I can zoom in though if anyone needs. Okay, cool. So we got a scopeless function. I kind of cheated. This isn't purely scopeless. If it was purely scopeless, it would be faster. But I just wanted to make sure that we are passing scope to make it a fair comparison. We also have a bound, and then what that does is it binds this and then calls the function. And then finally, we have a scoped one, and a scoped one means we create the function in line, basically, right? So the idea behind it is, this is using Node V8 as well. And if I run it, so what you'll notice is the scopeless, I'm running 1 million runs, so yeah, these numbers are kind of okay. So the scopeless one takes a second, the bound one takes 2.5, and the scoped one, which is an inline function, is taking 5.7. And I mean, there's a lot of theory behind this about why it actually happens and stuff like that. The main idea is the scopeless one right at the top, it's really fast because of the fact that it doesn't actually have to create a function. It's just there, it's a reference, it calls it with a certain scope. The bind is essentially you copying and pasting it. So the fact that it's faster is quite interesting. And this one here is actually super important. I mean, we use this a lot. It just makes life really easy when you write nodeJS, when you write JavaScript, right? I'm basically just referencing Y out here. And because of that, I'm like, okay, it should work, but it's significantly slower.
Can I ask a question?
Yeah, of course.
If you take the binding of the line 8, if you just move that up, if you move that out of the closure, wouldn't that give you the same speed?
That would. So the reason why I use this as an example is because a lot of the times people use these kind of things would be function.bind, they would do this, and then they would pass in their parameters. And the reason why they would do that is because they would want to call a function with the things. And that's basically what this demo is meant to do. But on the note of what you just mentioned, here's a really fancy trick. So this is using var. Var is ES5, which we used to love and now we don't. And if we compare it to, so what I've done now is I just changed var to let, right? Hopefully this doesn't embarrass me and it actually makes sense. So what do you think is going to happen? Anyone? Yeah? It gets slower. How much slower?
Huh?
How much slower? We got time. So you can see here that let turned it into 11 seconds instead of 5, right? So a lot of the things that we were accustomed to in ES5 and like the syntactic sugar is really like annoying and I want to be able to do all of these kind of things. That's a pure indication of the certain, the way Node basically progresses is usually ES6 or whatever new JavaScript syntax comes out. It's really fun, it's really sugary, it's really nice. Everyone jumps on board, they're like, this is awesome. It's usually implemented in pseudo JavaScript, like very, very high level. It's not optimized yet. I mean, Node 8 just got the turbofan, exactly, instead of the other one, which was with C. Anyways, generally speaking, JavaScript is constantly... Pardon? Crankshift. Yes, thank you. Yeah, so basically, it's always worth keeping this in mind. It's like these ES6 features are really cool, but there's a catch. Okay, so this one is JDIO, which is just do it once. This basically falls exactly into what you said. So it's if you are going to use a bind, there's nothing wrong with that. Do it inside of the constructor or do it somewhere outside. Don't do it inside of a loop, and don't try and do it so that you can pass functions across, like arguments to functions. In fairness, I wrote a very, very unfair example, right? Again, with the base that you had. But the reason why I've done this is we provide plugin interfaces for people to add adapters to DeepStream.io. And we've seen some really interesting ways JavaScript's being used. So, right. So what I've done here is, basically, okay, this is really, really obvious. If you're doing a JSON.parse outside of a loop, it's a lot quicker. I mean, there's nothing really to it, or if you set properties and stuff like that. However, it does go on a bit more. So the next thing is memoization, right? So memoization is really important in most programming languages. The idea behind it is if you call a function, that function has, let's say, static context, and then you call it with certain arguments, it will always return a deterministic result. And based on that, if you call something like multiple times, the first time is really expensive, maybe, and then after that it's super cheap. Now, just when I was writing this talk, I found something really fun, which is, I'm using isNam, right? Is that cut off? Okay. I'm using nam here. And what I'm doing is, and I've seen this inside of our code base just a couple of days ago. So what I'm doing here is I'm doing isNam, and I'm doing it on the loop. And in the second call of type of number, what I'm doing is I'm saying, I'm going to cast it to a number first, and then I'm saying a type of. Just doing these kind of things, again, it's very syntactical, gave me a performance improvement of 3.7 milliseconds, which should be quite consistent, to, yeah, okay, maybe not that consistent, but somewhere around that range. So basically, memoization is really important in terms of being able to, to make sure that if you're going to do something expensive, like parsing a number or something like that, you keep it in memory. The other thing, again, is the JSON aspect is quite important. It just, if you have an entry point into any server or any kind of nodeJS thing, and you're going to do something really expensive, and JSON.parse is one of the most expensive native things that you can do, just remember to keep a backup of it. You could do a condition and say, if my JSON already exists, use that, otherwise try and parse it. I mean, up until V8, parsing something usually was put out of a try-catch, it de-optimized it, there was a lot of negative implications behind that. Okay? Yeah, and this stands for, or never do it at all, which seems very odd to people, but the idea behind this is we have hot paths in code bases, right? So in our case, so what DeepStream does is I would send my JSON object, which is serialized over the wire, to the server. The server has the option of checking it against permissions, its content, but it doesn't have to. It has the option of manipulating its state and transforming it, but it doesn't have to. So I'm not going to say, okay, everything that comes through my messaging pipeline will be parsed so that everything else can use it. You have to make that choice between having a really flexible API, and that API is basically the ability to say, you'll always receive something that's parsed. VS, I can save a lot of this. And one of the improvements that we've done in our last release was an improvement about 15 folds, just by saying the code now basically just roots it and ignores things that it doesn't have to do. So it's a very important thing to keep in mind. And again, it is nodeJS, and because it's nodeJS, it's a single thread, so the more you bail, the better. Okay, this one's a pet peeve of mine. The reason why this is a pet peeve is because we have this issue. We introduced an issue inside of our code base because of the fact that we moved from old storage formats to new ones. And because of that, so the idea behind it pretty simply was, initially we had a JSON object that was _d, and inside that you'd have your data payload, and then inside of the top layer object you'd have all the properties. So it's like the version number for version conflicts, flags that were set with and stuff like that. The new one had a DS object, and then everything was high level. And the reason why it was high level is because it just makes it really easy for you to like query databases and such. But the problem that we had was our API was set name data. And that data there was already parsed, so because we'd done that issue that I mentioned earlier. And because of that, what would happen is I'd be setting it in both my cache and my storage layer. So what essentially happened at the end is we would be serializing data twice, which was really expensive. And again, because of the fact that this is an interface, we thought, hey, this makes sense. We want to give people the ability to pick how they want to serialize their data. And we still want to do that, so I'll get to that in a sec. So we used to do 2 calls. And what we want to do instead now is we want to have the ability to say, actually, DeepStream can set the serialized data for you instead. And then by doing that, it would just pass you a string that you would blindly insert into your database and not care about. So it would make it really quick in that sense. And because of that, this encapsulates the whole concept of like memorization / mainly just do it once, which is if I want to serialize the data in the cache, then serialize it, awesome, set serialized data, then I'm now holding it in my scope. And then when I go forward again, if I already have it, I'm going to use it. So this seems really basic, seeing it right now, obviously, but the idea behind it is, it's, lots of people do it. Okay, so this one's fun. Sometimes it's ethical to cheat. Again, everything I'm saying basically is more or less go against your natural developer inhibitions of writing clean code and instead write crappy fast code. It's not exactly what I mean, but... So, okay, let's look at this. So I'm gonna run something here, and I actually got this out of our code base as well, so, which is cheat. So my cheating code took 7 milliseconds, and my ethical comparison where I make sure that everything makes sense took 500. And let's take a look at what that actually means. So I mentioned earlier that every single record that you have in the system, it can basically have, it has flags. So it could say, I want to be able to get an acknowledgement back if I ever write anything. It can also mean that, again, well, there's more, we don't have more stuff yet, but there's more stuff that we will use for it. So this is actually something I copied and pasted out of our code base, just, which is quite bad, but it makes a lot of sense, right? So the idea behind it is we already have this JSON flag, but our API itself says you can send down JSON, and that JSON that you send down can specify that, hey, I have a value or I don't. And so what we realized was one of the biggest wins that we got out of the code not biggest wins, but one of the bigger wins we got out of the code was by doing a comparison against the serialized thing without having to parse it, it just made it that much quicker. And so initially what we were doing, we were writing unit tests, we were going like blah blah, we're going to create a JSON object, we're going to do this, we're going to do that. And then we're like, if this is the only sole interpretation of a JSON object I can get, but I still want my API to actually use JSON because I want to extend it in the future, then this is an awesome shortcut. I mean, your unit test will pass regardless, right? So it's awesome. Okay, so.
But then when you have bigger JSON object later, you then have to look for partial match, right?
Well, so yeah, so it gets into that kind of weird thing where it's like, what's faster? Is it faster to pass something that's actually doing that, regex it? Those are things that we're going to have to figure out as it goes. I mean, in an ideal world, we would have used, you know, like an actual byte and bit shifting and stuff, but it's JavaScript, so, you know, it's fine. Okay, well, what I mean by that is obviously that it's like JavaScript is meant to be something really, like it's really fast, but it's also meant to be like really easy for you to contribute, fix bugs and stuff, which is important. Okay, so that's all my little code widgety kind of things. This is a pretty cool proverb that I spent the entire day at work looking for. Make not a fence more expensive or more important than the thing being fenced. It rolls off the tongue really naturally. The general summary of what I mean by that is avoid spending your entire time doing I/O, right? If you're building a server, regardless of the fact that it's if it's a HTTP server, if it's a WebSocket server, if it's TCP or anything like that, what you'll always realize is you spend the majority of your time talking with a network layer. You're talking to sending packets, receiving packets, and stuff like that. Especially in nodeJS, those kind of things are really expensive. So I mean, there's a lot of really good talks about performance and stuff. One of them is basically the MQTT. So MQTT also wrote their own server. It's a network protocol. They managed to increase performance from 20,000 writes a second to 200,000. And a lot of it was contributed towards this exact line here. So there's this thing in Node, or in most languages, that's called corking, where you get it to buffer all of these messages up front, and then you can just flush it down to the network layer in one go. That's not what we've done. So the two decisions that we've done is, first off, we let users decide what their own real-time tiers do, right? So generally, when you're writing a server and stuff like that, especially if you claim that you do stuff in milliseconds, what it means is someone tells me something, I'm going to tell everyone else about it as soon as possible. It's like you try and close that gap. But there's a lot of secondary data that's not really important. So if I subscribe to a topic, I can wait for another 20 milliseconds, for example, up until I get an acknowledgement back. That's not going to make a difference. Or if I do a write acknowledgement, I think my user will be happy to be able to wait an extra 150 milliseconds, for example, until he gets confirmed that whatever he done was saved to the database. So because of that, what I've done is we added outgoing buffer timeout, which is now, am I doing the time, by the way? There's a few, okay, awesome. Right, so this is going to be quite fun. So prepare to be amazed by, okay, so this is really cool. This came out since Node 6. Node 6. Before that, it was Node Inspector, which was an extra kind of layer that you had to build on top, module that you had to install. And now, ever since 8, they really made performance like parts of nodeJS, which is amazing. So this here is now starting nodeJS, and then what that means is, if I go to Chrome Inspect, yes. Okay. Yes. Okay, so this is Chrome Inspect, and Chrome Inspect does stuff, but it has this really interesting link. And when I click on it, it now adds, let me not make that full screen so it doesn't cut off. Okay, I can't do that. So what this does is it's basically going to allow you to record all the CPU cycles that are happening in the process. Okay, so let's see, I'm going to start. And I am now going to run a test. What this test is going to do is it's just going to batch the server with 25,000 updates. And that's all the updates that it got back, so those are all the apps. And then ideally, I'm going to stop here. And what you can see here is very minified. Thankfully, Chrome is built inside all of that. Okay, so what you've got here is, so this is your CPU basically, and it's going like, okay, for a certain amount it was just like packed up at the top. And then down here, what it does is it tells you how much time it spent specifically inside of each individual pool. Like, so each function pool that you have. And you can see it's very long. So we spend a very small amount of time in functions, but because we have quite a large code base, it's quite a large kind of chain reaction kind of thing that happens. So if I go all the way down to the bottom, and yes. Okay, so you got a lot of, okay, I kind of feel like I need to zoom in more. But it's one of those things where they draw it in canvas and they don't respond to zooming. Let me try to do that, yes. Okay. Alright, so basically it's doing a lot of stuff. Okay, so the idea behind it again is every single time it goes down, this is actually meant to be a more performant one, ironically, but it is. So the idea here is that this is where it actually flushes the messages, right? So what's happening is it's getting 25,000 messages. It's doing them all in bulk, and then it's batching all the messages that happened in 20 milliseconds in batches, and it's sending it back to the actual client. So this is when it happens in 20 milliseconds. Now, I think, I'm hoping I'm not like completely wrong with this. If we edit the configuration, nope. Yes, okay, so it was 20 milliseconds, right? And if we do that again, this should be a lot worse, hopefully. Otherwise, I'll just spend the last week doing nothing. Also, how do I close this? Does anyone have skills? Yeah. Okay, sweet. Alright, so let's try that again. I'm still getting used to a Mac. Okay, and I'm just running that test. It's running all of those things. I'm going inside of stop. Pick that again. So, I mean, I don't know if you